When you need to factor a polynomial, it can be tricky to know where to start. We're going to look at how to factor polynomials using a step-by-step process, starting with looking for the greatest common factor, and then looking at how many terms the polynomial has. Let's start with 8x squared minus 12x. The first step for factoring any polynomial is to see if there's a greatest common factor. This polynomial has a greatest common factor of 4x, and when we factor the 4x out, that leaves us with another factor of 2x minus 3. Your next step should always be to look at that remaining factor, the 2x minus 3 in this problem, to see if it can be factored anymore, and this one can't, so we're done with this. Now let's look at how to factor 9x squared minus 16. There's no greatest common factor, so now we'll look at how many terms we have. We have two terms, so let's see if we have either the difference of squares, the sum of cubes, or the difference of cubes. 9x squared is a 3x that's been squared, and 16 is a 4 that's been squared. And with the subtraction in between them, that means we have a difference of squares. So now we can use our factoring formula for difference of squares to factor this into 3x plus 4 times 3x minus 4. And we're done. Now let's look at x squared plus 9. There's no greatest common factor, so we'll count the terms we have. With two terms, we might have the difference of squares, the sum of cubes, or the difference of cubes. Well, x squared is an x that's been squared, and 9 is a 3 that's been squared. So this looks an awful lot like the last problem we did. But this one is a sum, and the sum of two squares will not factor. So that means x squared plus 9 can't be factored any further. It's just x squared plus 9. Now let's look at 27x cubed minus 8. There's no greatest common factor, and we do see that we have two terms. 27x cubed is a 3x that's been cubed, and 8 is a 2 that's been cubed. Since there's a subtraction between the two terms, that means we have the difference of cubes. We'll use our factoring formula for difference of cubes to factor this as 3x minus 2 times 9x squared plus 6x plus 4. So how about 64x to the 6th plus 27? There's no greatest common factor, and we do have two terms. So can we make this fit into one of our factoring formulas? Well, 64x to the 6th is a 4x squared that's been cubed, and 27 is a 3 that's been cubed. So that means we have the sum of cubes. We'll use our factoring formula for the sum of cubes to rewrite this as 4x squared plus 3 times 16x to the 4th minus 12x squared plus 9. Here's our next example. X squared minus 8x plus 16. There's no greatest common factor, and this time we have three terms. This trinomial does fit into a factoring formula for trinomials because what we have is a perfect square trinomial. If we think of that middle term as negative 2 times x times 4, and we think of the 16 as a 4 squared, this fits into the second of those two formulas for perfect square trinomials, which means we can rewrite it as the quantity x minus 4 squared. Now let's look at 2x squared minus 5x minus 3. There's no greatest common factor, and we do have three terms. This doesn't fit into the pattern for a perfect square trinomial, so we'll have to use a different factoring method for it, and think of this as a product of two binomials. 2x squared is a 2x times x, and negative 3 is some combination of 3 and 1, where 1 has a negative sign and 1 has a positive sign. To get that middle term, we'd need to put those numbers here. So this factors into 2x plus 1 times x minus 3. Now let's factor 8xy plus 2x plus 12y plus 3. There's no greatest common factor, and this time we have four terms. So with 4 terms, we're going to try factoring by grouping. If we group the first 2 terms together, we can find a common factor of 2x and a remaining factor of 4y plus 1. And if we group the last 2 terms together, we have a common factor of 3 and a remaining factor of 4y plus 1. Now we have a common factor of 4y plus 1 and a remaining factor of 2x plus 3. So there you have it. If you follow these steps, you'll have a good strategy for factoring pretty much any polynomial.